Let's put our relative age dating skills to the test by practicing with 3 different examples that each increase in the level of difficulty with each one. So first, let's start with the simplest of these examples. In the picture, we see multiple rock units, including one that is a dike that has intruded into the area and a fault that has cut the area as well. So when we look at these units, we were going to work from the bottom up because when you are applying your principles of relative age dating, you always work from the oldest to the youngest. And the basic principle of relative age dating is that the oldest layers are on bottom and the youngest layers are on top. So we work from oldest to youngest. In this example, we see layer C sitting at the very bottom, and based on the available rock units in this example, we can safely assume that C is the oldest of the units pictured. So C is first, as it is the oldest. Sitting directly above C is layer B. So layer B would be the second oldest unit in the example. Then we have layer A. So layers C, B, and A represent a sequence that were all deposited one after the other, beginning with C and ending with A. Now, after the sequence of C, B, A were deposited, we have some interruptions going on to the area. So the first interruption is going to be D. D is an intrusion, and we know that D came after C, B, and A because it cuts across all of them. So D cuts across C, B, and A. Now, the final event that has taken place in this example is E. E is a fault, and this fault has disrupted the area and cut the rock. Now we know that E came last because every other unit in the image has been affected. So D has been offset. It has been broken from its original position. So we know that D was already there, meaning it was older than the fault. So the correct order for this example would be, starting from oldest to youngest, would be C, B, A, D, then E. In the second example, we see a slightly more complex situation. So reviewing the general layers and units in this particular example and working from the bottom up, we can begin by stating I is the oldest unit in this example. So we see I, B, and F were deposited in sequence with one another, according to the principle of superposition. Now, do you see how the top of layer F is not a straight line? It is a wavy line. That means erosion has taken place there and an unconformity has been created. Once we see that erosion has taken place, we have to stop and evaluate what will happen next. We have two options going after F. We either have the fault that has occurred or we have layer M. So we know that the fault happened after layer F was deposited because layer F has been affected by the fault, but M has not. So layers I, B, F were deposited, then the fault occurred, and then layer M was deposited on top of that eroded surface of F. After M, we have layer R being deposited on top of it, and then finally H was intruded. We know that H was the very last event because it cross-cuts every unit in the example. In this final example, we see something that is more realistic, and that simply means that it's going to be a bit more complex. So looking at what's going on in the left-hand corner, we can safely assume this is the oldest area of the example. And rock unit E is an igneous rock body. So with it being an intrusive igneous rock body, this tells us that the sequence of G, L, and C were already in place. They are the country rock for which rock unit E intruded into. After the intrusion has cooled, we see that fault H occurred. We know that fault H occurred after the intrusion because the intrusion was also affected. It has been broken by the fault, so we know the faulting occurred after the intrusion cooled. After the fault, rock layer M was deposited. We know this because it is not faulted, it is not broken by fault H. So that means it wasn't there when the faulting occurred and must have been deposited afterwards. Following rock unit M, we see rock layers D and J. These were all deposited in sequence with one another. After rock unit J was deposited, we see that rock unit A was intruded. Now we know that rock unit A occurred at this point in time because it cuts across the entirety of rock unit J. Now at the top of rock unit J, we see a wavy line which indicates erosion had taken place. So there may have been additional rock units above rock unit J that were present when rock unit A intruded. However, they have since eroded and have been removed from the rock record. Following the erosional event, we see rock unit N being deposited, followed by K and B. These rock units were tilted to an angle and then eroded flat. At that point in time, rock unit F was deposited.